Okay. Let's take this example. Market. Okay. This market have two different brands of eggs. So we can name the two brands, for example, brand 1 and brand 2. So the market, it's have two different type of brands. Information about eggs from the experience. Look, the information come from where? Experience. Like lambda, which is the error, okay, or the cost about taking some action. It's come from the experience. Probability of the broken eggs come from experience. Usually when we have, for example, 1,000 egg, we have 10 or 20 broken egg, for example, and so on. So the information from the experience as following. Of course, the two types we said, brand 1, brand 2. We don't want to give specific names, okay? And we take from brand 1, 800 egg, from brand 2, 600 eggs. The broken eggs, we will give it letter A. Rate, it's 5%. 5% means 0.05, yes? 5%. Okay, the question here, what is the probability? So we ask about posterior probability that an egg coming from brand 2 will be broken in 1 day. Okay. First of all, we should know what's the probability of or the distribution of the probability between BR2 and BR1. Let's say they have equal distribution about broken egg. So we imagine that the broken egg, half of them come from BR1, half of them come from BR2. Let's use the logic to answer this. Then we can use the Bayesian rule general, not decision rule, to calculate the posterior probability. This is a question about not the classification, it's about posterior probability. We will take examples about the classification, but we will simplify this Bayesian rule to use it for classification. Okay, so using only the logic here, we know that we have a total of 1,400 egg. Why? Because from brand 1 we have 800, plus from brand 2 we have 600. So totally we have 1,400 egg. Okay, 600 come from brand 2. We have 70 broken egg per day. From where we get this number? 104 egg we have, multiplied by the percentage of broken egg. It's given to you here. It's given to you. So 0.05, it's broken egg per day. Okay, if we assume equal distribution, this assumption, in the exam, we will not leave the assumption for you. We will tell you that 35 come from brand 2 and 35 come from brand 1. If we said it's equal distribution. This brand, we have 35 eggs. This brand, we have 35 broken egg. So the probability of BR2 being broken, how to calculate the probability of something? The number divided by the state, yes? Or the size of the state. The size, how many brand 2 we have? 600, 35 broken. So what's the probability of being BR2 and broken? 35 divided by 600. So this comes from where? This is a broken egg. Okay, yes, broken egg. And this one what? BR2, number of eggs in BR2. So probability of BR2 being broken is 35 divided by 600. This using the logic, the common sense, yes? Using the rule, we have the rule. This one what? That we need to calculate it. It's conditional, yes? Conditional, and we know the conditional. We write it there, yes? She write it. I forget your name. It's good that I don't remember the names usually. I remember any name here? Who guessed I remember his name here? I don't think I remember any name. I don't know your name. He raised his hand. Actually, I forget your name. To be honest, I'm not good in memorizing the names. If you tell me your name, he's within the senior project, yes? I don't know your name. What's your name? Muhammad. You have a group with you, yes? Who? I never saw you. Okay. So we have this rule. Probability of egg to be cracked or broken come from BR2. This one we need to calculate. So to calculate it, it's probability of BR2 given K multiplied by probability of K divided by probability of BR2. Okay, let's see what we have here. Probability of 2 given K. Probability of the broken egg come from 1. We read it like this. Probability of the broken egg come from brand 1, it's 0.5. Because we said equal distribution means equal probability for broken from BR1 and BR2. And the probability of BR2 and broken also 0.5. What we have also, probability of K, broken egg, it's given to you, yes? It's 0.05. Probability of BR2. How to calculate it? It's number of BR2 divided by the total number, yes? Probability of something. It's, for example, we mentioned it before two lectures, yes? We have box, and this box have just balls, okay? What's the probability of red balls? How many red balls we have? 4. Divided by, what's the total number? 10. So divided by 10. What's the probability of blue? Equal 6 balls blue divided by 10, the total number. Same issue here. Probability of BR2. It's number of BR2, which is 600, divided by the total number, 1,400. Okay? So we can calculate probability of BR2. It's here. Probability of K. Probability of BR2 given K. K means broken egg. Okay? By the way, you don't need to take photo. Okay? Especially without permission. You did not ask me. Because you will see that this one, I bought it for you from where we calculate everyone. So this given to you with the lecture note, by the way. Okay, so calculate. So it's 0.5 multiplied by 0.5 divided by 600 over 1,400. You will find that the number is same like this one. So if you calculate it using calculator, using anything, by the way, we allow calculators in the exam because it's not mathematics, yes? So in discrete mathematics, we don't allow. But here we allow it. So it's 0.58. Okay, so this is the calculation one. Another example. A member of, where is Sarah? A member of consulting company rent a car. I think cars should be rent cars at a rate of 60% from first enterprise. Okay, so we have company, consulting company, any company. Rent cars from 3 different companies or rental companies, okay? So 60% from the cars come from the first enterprise or the first rental company. 30% come from the second enterprise and 10% come from the third enterprise. If 90% of the vehicles, means the cars, okay, coming from the first enterprise, let's give names, okay? So first enterprise, we will name it A1 because I'm giving in the answer, I give it A, yes? So A1. Second, I will name it A2. Third, I will name it A3. So from A1 20%, if 9% of vehicles come from first enterprise, 20% come from A2, and third enterprise, which is A3, the remain, yes, require maintenance. So this is a maintenance rate. What's the probability of the car from specific one need maintenance? 90% of A1 need maintenance, 20% from A2 need maintenance, 60% from A3 need maintenance. Okay. It's look complicated, yes, but it's easy one. Just you need to follow the simple steps. What is the probability that a vehicle rented to the company will require maintenance? We mentioned any condition here? No, we did not mention any condition. So if we said B means the car need maintenance, so we need the probability of B, yes? How to calculate the probability of B? This general B, not B belong to specific one. Don't look to the mobile. Not from the mobile, from your brain. Okay, good. Okay. You remember the rule that we see from here? This one that we need to calculate. You remember how to calculate this one? It's with summation of probability here. B given A, yes. We speak about all A, G from G equal 1 to M multiplied by probability of I already gave it for you, that rule. Okay. You see the rule? What's this one? This one, probability of specific class given the feature, yes? This is probability of a feature. How to calculate it? From this one. Probability of the feature given a specific class, it's given to you. We have the probability of the car come from a specific company. It's broken, need maintenance. It's already given to you. And this one also given to you. Probability of the cars come from enterprise 1 or A1. It's equal 60%, yes? It's given to you. So this is our first one. You need to calculate it using this rule. Okay, so return to our question. So our question is about the probability of B means a car need maintenance. So probability of the car need maintenance, it's equal the summation that the cars come from company 1 need maintenance and car from 2 need maintenance and car from third company need maintenance multiplied by the probability of every class. So it's summation for j not or equal 1, 2, 3. Why 3? We have 3 companies. Probability of B, the car broken, come from specific company multiplied by probability of the company. By the way, you can answer it using the common sense. What's the probability of the car need maintenance? How many cars need maintenance, or the percent of car need maintenance from the first company multiplied by the percent of the cars come from first company, plus probability of the car broken come from the second company multiplied probability of second company plus probability of the car need maintenance. Probability of A1 equal, it's given to you, 60%. So 0.06 probability of it's given to you here. Probability of the broken car come from, sorry, this one, 0.09. Here 0.2. Information given to you, just you need to mark summation. Okay. This first, okay, what is the outcome from? Second enterprise need multiplied by probability of A2 divided by, so this is the given information for you. Probability of A1 A2 and A3, and the probability of B given A1, probability of B given A2, probability of B given A3, all this information given to you in the question. So for the first part, we need to calculate the probability of B. So probability of B means probability that the car need maintenance. We can calculate it from this rule. Yes. Probability of B, it's equals summation of I from 1 by the company need maintain. The second is probability of A, B. So probability that the car come from broken or need maintenance, it's equal probability of B2 given A2 multiplied by probability of A2 divided by the summation or divided by probability of B. This same probability of B actually equals the summation of I equal 1 until 3 probability of this one. We calculate it. This one given to you. So 50% of the car coming from A2, it could be broken and need maintenance. It's better not to bring car from A2, yes. This one probability here. Okay. Like this, we almost finished week 4. Let's now start with week 5. I will stop this video. I will merge it later with week 4.